geometric sequences. So we're going to be looking for some type of pattern within each of the groups of numbers. So formal definition is a sequence in which each term after the non-zero first term, so anything that's not zero, is found by multiplying the previous term by a constant, called the common ratio. So it can't be zero because then you wouldn't have a geometric sequence. It has to be greater than 1. So for instance, if we looked at the numbers 1, 3, 9, 27, 81, you notice each time that they're multiplied by 3. So that's what we're looking for. And what I mean by a common ratio is you take the second term and divide it by the first term. So in this case, we had 3 divided by 1. So our common ratio is 3. And we should be able to take any two consecutive numbers and figure out that common ratio and then compare it to what was found to begin with. So for example, if I had 1, 4, 16, 64, and so forth, if I take 4 and 1 and divide them, I get 4. Then if I looked at the next two numbers, let's say 64 and 16, and divided those numbers, I'm getting 4. So you should see the pattern. When we look at example 2, when we divide those two numbers, it's 3. But if you take, like, say, 5 and 7 and divide that, you're not getting 3. So therefore, this is not, example 2 is not a geometric sequence. So number 1 is a yes. And then looking at the other ones, if we go 4 divided by 4 goes into 6 how many times, we get the ratio of 3 halves, or 1.5. So let's look at another one. Let's take the 13 and a half and 9. So we've got 13, I'm just going to make this 1/2 divided by 9. A little more work in this one, but if you had a calculator very quickly, you could figure out exactly what the ratio is and if it actually equals 1.5. I, on the other hand, am going to do it longhand. So I'm going to have 27 over 2, because I go 2 times 13, which is 26, plus the 1 is 27, and then that's all over 9. So that means I'm going 27 over 2 times 1/9. When I look and cross cancel, I have 3 and 1, because 9 can go into 27 3 times. So then I have 3 over 2, because I go 3 times 1 is 3, 2 times 1 is 2. So I get that ratio. So make sure you're checking that the ratio is consistent, not just looking at it and saying, well, those are decimals, that's not going to work. You need to check. Alright, so we're going to look at the next few examples and figure out what the common ratio is first, and then find the next 3 terms. So let's look at example number 4, and we've got 5 and 20. So to find the common ratio, you always take the second term and divide it by the first. That's going to be 4. So I know that I'm multiplying by 4 each time. So to go from 320 to the 5th term, you're going to take 320 and multiply it by 4. So that's 1280. To do that again to get the next term, that is going to be 5120. Fix that. And then lastly, you've got 20,480. Okay. So with this, we're just going to keep going down each of these examples. First, always finding the common ratio. So if we look at number 5, well, we take 30 and we divide that by 15, you're going to get 2. So that means I'm doubling it each time. So the next term would be 120 after 60, 240, and then 480. And please pause this video at any point just to make sure that you're getting what you need for information. Example 6, again I'm going to go negative 88 divided by 176. Always remembering that a negative divided by a positive is a negative. So I didn't mean to write -1. So now we have to figure this out. 88, is that half of 76? And if it is, I'm just going to take 88 and add it together. It is. So that means that we're multiplying by -1/2. So every other term is going to be -1, and we just take half of that term. So after 44, it should be -22. After that, it should be +11, and then -5.5. Okay. Next one. This one, we've got 12 divided by -8. So like we talked about before, it's going to be a negative number. 8 doesn't go into 12 evenly, so I would just divide by 4 top and bottom. So you're going to get 3/2. So each time, basically we're multiplying by 3 and dividing by 2. And every other one's going to be negative. So I know the fourth term's going to be negative, and then the seventh term. So at this one, I'm going to take 27, times it by 3, and then divide by 2. So we get -71 seconds. So I'm going to let you continue finishing it, and we'll talk about what you see with the pattern next time. Then there's a formula, so that way you can try to figure out what the 10th or 20th or 30th term in the sequence is. And basically, the information that you need is what the first term is. So as long as you know the first term. So in our case, the example that we have up on the top, 2 is my first term. So a sub 1 is 2. Common ratio, well, we know the common ratio. We just have to take the second term divided by the first and get our ratio. And then the number of terms that we want to find. So in this case, we want to find the 10th term. So again, it's just a formula. You just need 3 bits of information. You need to know what the initial term was, what the common ratio is, and then we just need to know what term we want to find. So you want to find the 10th one in the sequence, you want to find the 13th term in the sequence, whatever that might be. So over here on the left-hand side, what I've done is I've plugged in that information. So A1 becomes 2. That R becomes 3, and then n minus 1, that's going to be 9, because I'm going to take 1 away from 10, because 2 represents that first number. Once you multiply all that out, always doing exponents first, you get 39,366. Okay, so let's try another one together. We want to find the 7th term. The geometric sequence tells us that the first term is -5, and R is 4. So we don't have to do any work ourselves, we just have to plug in that information. So you're going to have this. So you have -5, which is your first term. We're going to subtract the exponent, so you've got times 4 to the 6th power. And now you have to figure out what that answer is going to be. Again, I want you to find that answer, and we'll talk about it next time. Okay. Last but not least, the common ratios. So what we have to do is try to figure out what that middle term is based on knowing the first and the third terms. So in this case, when you think about it, a sub 1 is the first term, a sub 2 is the second one, and a sub 3 is the third one. We know the first and we know the third. So we're going to have to plug that information into our formula. So we're going to have a to the second, which we don't know, all over -3 equals the third term over the a sub 2. That's just doing common ratio twice. From there, you're going to cross multiply. So in this case, you have a times a, which that makes sense. Then -3 times -48. So in this case, when we multiply 48 times 3, you're going to get 144. I like the answer of 144 because it's a perfect square. So in this case, our a sub 2 squared is going to equal 144. The thing we have to remember with these types of problems is when you take the square root of each side, it's going to end up being a sub 2 equals plus or minus 12. So depending on what our sequence is going to be, we could have 2 different answers depending upon what was given. That concludes this section and the last section in this chapter.